And we are now recording, so I wanted to make the last few announcements now, and basically some of the same stuff I just told you. I want to get it out there so everybody who's listening, if anyone listens, can get it. First, student course evaluations are open. Have you done yours yet? I did. Did it take you very long? Okay. So please get those done. If you do want to wait till the end of the term, you can, but please don't forget to. If you're likely to forget, go on and get them done now while you're thinking of it. I know when I was an undergraduate, boy, finals exam week came, and about that last final, I was basically brain dead. I shut it down and would forget anything, so please don't do that. Get it done rather than forgetting it. Okay, number 2. As soon as, yes, ma'am.
This is a single.
I'm sorry?
This is a single.
That's a single, yeah.
I don't see it.
So you're going to do at least better than that.
I hope so.
Well, you can't go any worse. You got that. Okay. All right. Okay. So, all right. Thursday is the last day of class. That means your research papers are due by Thursday. I'd rather have them today or tomorrow, but Thursday's the last day I will accept them without your losing points. Huh?
Test 3.
Okay, test 3 also is due as soon as you can get it in.
So it's not due particularly Thursday.
Well, I wouldn't hang on to it while I'm working on the final. I mean,
Yeah, okay.
yeah, I would try to, because I'm giving you the final on Thursday, so it'd be better to get that in. Okay? So Thursday is when your research papers are due. If you turn it in to me after Thursday, you're going to be losing points. You'll still get credit, but you will be losing points. So get them in before Thursday, by Thursday anyway. Thursday morning at 9:30 or shortly thereafter, I will pass out to you all the tests, not the research paper, but all the tests that you've done so far. And that will be the drop dead date for them too, because the others will be out in people's hands, and that's not right for the correct answers to be floating around out there, and other people might lay eyes on them and then get, it deflates your score. It diminishes what you have done when you did it, basically, honestly. So everything, the other 3 tests, I'll be returning to you. All that have been turned into me on Thursday, and that's the last day to get those in. So Thursday, 9:30, okay, get those done, okay? I'll return those to you so you can ask questions about anything you may have missed or don't understand. All right, then we'll finish as far as we can in chapter 6, and then at the end of class on Thursday, I will give you your take-home final. It will be 2 parts. The first part will be the chapter 6 part. The second part will be the comprehensive part. There will be questions on all chapters that we did. Okay. Thank you. Okay. Any questions? Okay. All right. Now, where we left off last time, we had done this example, example 3. Okay? We're on the top of page 405. It's chapter 6, additional topics in trigonometry. 6.1 is law of sines. Okay? Boy, why was that so far back there? All right. We were going to start on do example 4. Okay. I'll use this slide for 4. This slide has nothing to do with 4, but let's get to a dark color. Okay. Here's what you're given with example 4. Little a is equal to 15. little b is equal to 25. And angle A is equal to 85 degrees. Okay? Now, kind of hard to do. It usually helps to draw pictures, so try one. Okay? Here's going to be your baseline. Okay? Now, they actually did a dotted baseline, which probably is a good idea, so let's change that. Okay? Okay. And that's supposed to be a straight line. Not a very good one, but that's supposed to be a straight line. Okay. Now, this will be basically your base. Okay. We don't know how long that's going to be, though. And they give us angle A, 85 degrees. That's awfully close to 90. Ooh, that's probably not close enough. Let me try it again. That's probably not enough, but let's call this 85 degrees. So this is going to be angle A. Okay? Now, side B, they're saying is 25. So let's take this up here and make this 25. This is B is equal to 25. Okay? Now, side A, the side opposite this, that's got to be 15. Now, just your picture there. If this is 25, that would be not very well done. 15 would be somewhere here. And guess what? It's never going to reach the ground. Does that make sense? A is equal to 15. Now, I can't say for absolute certain that A is the largest angle in the triangle, but it sure is going to be close. Because if it was 90, there's no angle could be greater than 90. Okay? So this is going to be, you could have another, say, 86. That adds to 171 and then a 9-degree angle. But guess what? There's no way that this B over here can be that much larger than this A. That means the angle B over here has to be a good deal larger than 85. It's not gonna happen, okay? It can't possibly happen. There's no way that's going to do. Now that's just a picture of it, okay? Now, if you don't believe that, go on and try to use the law of sines. Because with the law of sines, all you need is what? To what? Well, tell me what the law of sines is. Okay. Okay. You said sine capital B over little b is equal to sine capital A over little a. Is that how you said it? That's absolutely correct. And you know 3 out of 4. That's what you need. You need to know one ratio. And here we have it. Angle A, side A. We got it. And then the other third thing happens to be side B. So let's go on and try to solve this. Okay? Let's solve it for sine B. Now, you want to do that first, or you want to do it after you plug in the numbers? I don't care. Huh? After? Okay, well then solve it for sine B. Second?
Easiest thing to do. Do you want to get it by itself first? Or do you want
That's what I mean by solve by. Yeah.
What's easier, to plug in the numbers first or to solve?
It's 6 of one, half dozen of the other. I ask which one you want to do. You choose.
I think
Huh?
it'd be easier just to plug it in first.
You want to plug in numbers first, okay? So you don't know what capital B is, so it's sine capital B over little b, which is 25, is equal to sine of 85, right? Over 15. Okay, so now what do you do?
Yeah, sine B by itself.
How do you do that?
Multiply by 25 on each side.
Yeah, multiply both sides by 25. Wipes them out there, you got a 25 here. Okay, got it. So sine B is equal to 25 times sine 85 divided by 15. Okay, you can do it that way. You could reduce it some if you wanted to. Like 5 will go into this 3 times, 5 will go into that 5 times. You don't have to. It works just as well. So you find out what sine B is equal to.
One
1.6. So sine B is equal to 1.6. Is anything wrong with that picture? Just a question.
What do you got?
Is anything wrong with that picture? Okay, perfectly fine. Okay, how do you find out what angle B is then? If, well, only one showed up today. Okay, you through? Okay. So, yeah, like that.
So we have a test on Tuesday, right? Next week.
Huh?
Yeah, final on next week.
Yeah, your finals next Tuesday is 2 parts, right? Chapter 3 part and comprehensive part. Good, fantastic, excellent. I'll be returning your other quizzes and tests to you then Thursday morning. So how would you find out what angle B is?
Angle?
Yeah, that's what capital B is the angle B. It would be this angle down here somewhere. Well, what if that was your problem? How do you undo a sign? No.
Reciprocal?
Yes, good morning. Aaliyah is here. Okay. Middle part of the alphabet is doing quite well. Top and bottom, not here. How do you solve for B? How do you undo a sign?
Reciprocal.
Say again?
Reciprocal?
No. It's the notation is almost like reciprocal, but it doesn't mean reciprocal. No? What do you mean by that?
Page are we on?
Say again?
What page are we on?
We're on page 405, top of the page. Say again? Okay. Well, the angles are in degrees. This one's in degrees, so be sure you're using in degree mode on your calculator. But how do you undo a sign? How do you undo any function? How do you undo addition? How you undo addition is you subtract something, right?
On both sides.
Say again?
On both sides. Trying to get the side by side.
Okay, but how do you undo a sign then? You got sine B is equal to 1.6. That's what he told me. And he's happy with that. So how do you undo it? Okay, find your sine key on your calculator. I don't have one, no, not here. Find the sine key on your calculator.
Inverse sign.
Oh, inverse sine. Okay, that's how you undo a function, is do the inverse function. So do the inverse sine of 1.6. Error? I didn't think you made errors. Okay. Why? Come on now, you should.
Take the inverse of it.
Try 0.6 and do the inverse sign and see what you get. So
It's
that's,
more than one.
oh, it's more than one. That's what's wrong with that picture, isn't it? A sign cannot be anything outside of plus or minus 1. Ever. 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 So therefore, this is a no solution case. There's no angle that will fit those criteria. So even if you didn't see it in the picture, that it didn't look likely, when you got down to this point, you say, can't happen. When you saw that sine of B was going to be 1.6, that ain't no angle B that could give you a sine of 1.6. All sines are between plus or minus 1. Not going to happen. Okay? So, no triangle could be formed by those criteria. So let's move on to example 5. Okay? Again, they don't have this in thing. Here we have the situation of A is equal to 12 meters. B is equal to 31 meters. And angle A is equal to 20.5 degrees. Okay. Now, again, if that was a huge angle like 85 or 103 or even 80, not going to happen because the A is too small. But this A is a very small angle, right? 20.5 is small, so this opposite side could be that much less than B, I think. So again, we draw at least our illustration of it. It may not be very representative, but we'll put our angle A down here, okay? And this is only 20 degrees. So 45 would be there, 20 would be something like that. That may be a bit too small. So here's angle A of 20.5 degrees, okay? Now your side B is pretty long though, 31. So B is equal to 31 meters. So that's pretty long there. Your side A is 12 meters. So that's a little bit more than a third of that. Yeah, A looks like it could be long enough to do. In fact, it looks like it could go here. A is equal to 12 meters. Or it could even go here. A is equal to 12 meters. At least by my picture, it looks like it's a possibility. Let's see what happens. Okay? Again, how would you approach the problem? What would you try to go for first?
Say what you had in the picture.
Say that again.
Okay, would you say, maybe first you can, the formula.
What formula is that? Law of sines. How does that go? Sine B over little b, sine capital A over little a. Okay? We know 3 out of the 4, so we can solve for the fourth one. What would that be? Sine B, capital B, is equal to, okay, over what? 31. Okay, we'll do it that way. Is equal to sine of 20.5 degrees, which is 12. Okay? As long as you know 3 out of the 4, you can solve for the fourth one. So how do we do that? Multiply both sides by 31. Okay, wipes out the 31 here. And that gives you sine B is equal to what? Mm-hmm. Yeah. 31 times sine of 0.90. Yeah. 0 what? 0.047. Okay, blah, 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 blah. Okay. Does your heart sing better now? Yes, because this is between 0 and 1. Just barely, but it is between 0 and 1. So, you can tell me what B is, can't you? You say yes. How? Huh? Yes, you do. We just did it. How do you undo a sign? Of course. You got the number there, just do an inverse sign of that number. $64.7 degrees.
64.78.
Okay, let's do 3 digits. 64 point what? 0.8?
64.8.
Okay, 60 B is equal, approximately equal 64.8 degrees. Is that what you said? All right. That would be this angle right here. B would be 64.8 degrees. Now, my picture probably stinks, okay? But that's a possibility. But you know, there is another angle that also has that as a sign. In which quadrant would it be? Which quadrant's the sign positive?
First and third. First and second.
Is it a multiple choice answer? All students take calculus. All are positive in the first quadrant, sine cosecant in the second quadrant, take is tangent and cotangent in the third, calculus is cosine and secant in the fourth. First and second. Okay? So, is there an angle in the second quadrant that has that same value of a sine? Let's draw us a little picture here. Okay? 64.8 would be something up here. Right? Now, in this quadrant, the reference angle would be this, 64.8 degrees. Okay? So subtract that from 180, and what do you get? Say again? 94.7. Okay, 180 minus 64.8. Say it a little louder. B2 would be 114 point what? 115 point what? 2? Okay, 115.2 degrees. So we have two possibilities. This would be the one that's at 115.2 degrees. Okay, so we have two possible answers there. You could have this one with 64.8, or you could have the obtuse angle. Mine obviously is very correct or accurate, but 115.2. So since we have two possibilities for B, we have two possibilities for length of little c and angle little c. Okay? Now, which of those would be easiest to come up with first? Which you want to go for? The 64 or the 115? Let's just do one triangle at a time.
Say which one will be easier.
Say again?
You say which one will be easier to find out?
Okay. Pick a triangle. You're going to go on with 64 or 115?
Does it matter?
Pick one. 115. Okay, we're going to go with this one. Okay? And mine probably isn't drawn too well. So, then we'll need a side C and also, no, I'm sorry. This, oh, I put those in the wrong places. No wonder. You let me do that. What is wrong with you? Okay? These are not up there. Those are angle C's. Okay? Your B is opposite B, and the first one of those would be this one. There's your B is equal to 64.8 degrees, and this is the one where B is equal to 115.2 degrees. And that looks a lot better, because that's obviously an obtuse angle. This is an acute angle. Okay? Now, what we've got left to do is either one of two angle C's and either one of two side C's. Now, you wanted to go with the B of 115.2? Is that right? Okay. And which is going to be the easier thing to do? Calculate what side C is or what angle C is? Angle C, of course. How do you get that? And we call this B2 here. Say again?
Add them together and subtract from 180.
Okay, do so. 94.7. If you're doing, wait. That doesn't, okay, which are you using, 64.8 or 115.2?
Sorry,
Okay. Back off. I asked you which one of these two B's you wanted to use. The 64.8 or the 115.2? 115.2.
I copied the wrong one. It's 44.3.
24.3?
44.
44.3. Okay. So this up here will be 44.3 degrees. Okay. And we're calling this C2. Okay. Because it matches B2. Okay. Let's just do it real quickly and see. 510, that works. 510, that works. 6, 7, 8, that works. Okay? Now all we've got to do is get side C2, little c2 here. And how do we do that? How do we do little c2? Law of sines. And how does that go? A over sine A, is that what you said? Is equal to?
12 over.
Say again? Okay, yeah, but give me the law of sines first. A over sine A is equal to? Say again? C, okay, let's do, we're using C2 over sine of C2. Okay? You're using that one. Okay? So, you said this was 12 over sine of 20.5 degrees is equal to C2 we don't know over sine of 44.3 degrees. Okay? How do we find C2? Say again? How? Yeah, multiply both sides by sine of 44.3 degrees. Sine of 44.3 degrees. These wipe out, and there you have C2. So you tell me what it is. you figured it yet? Have you figured it yet?
So,
Okay. Say that one more time. Okay, I can't hear. Sorry. 23.93. So C2 would be 23.9 meters. Okay, 23.9 meters. Let's see if it makes sense. Amber's here. Okay, we're doing example 5 on page 405. All right, now what we have is 3 angles, 20, 44.3, and 115.2. Obviously, 24.5 is the smallest angle, so our A of 12 meters should be the smallest side. Okay? Your B of 115.2 degrees should have the longest side, 31 meters. So therefore, the angle C2 that we're doing here, that would be B2, C2 is in between those two, so the side should be in between 12 and 31, and let's round that to 24. And 24 looks like a reasonable number, okay? So let's just change that to 24. 24 meters. I swear this is such a pain in the neck. Okay, 24 meters. Okay. So that's our C2. But we have another possible triangle here, don't we? We have another possible triangle here, don't we? We have another possible triangle here, don't we? What's the other one? What's the other one? What's the other one? What's the other triangle? Okay, that's when the B1 is 64.8 degrees. Okay? With this B1, then we're going to have a C1 up here of here. Okay? This will be our C1, capital C1. Okay? And now our little c1 is going to be the longer side here going all the way there. That'll be our little c1. Sorry, this is getting pretty crowded here. So what do you want to calculate first? What do you want to calculate first? Angle C1 or side C1? How do you do it? Say again? 94.7. And how did you get that? 20.5, 64.8 together. Okay. You did the 64.8 and 20.5, which would be 85.3. Yeah, and that would give you 94.7. Okay? So, the one and last thing we need to calculate is what little c1, side little c1, which is now going to be the longest side of this triangle. And what is that side c1 going to be? Okay, we've got
Outside.
angle A, side A, angle B, side B1. Okay, angle B1, side B. That's the same B. And then you just gave me side C, angle C2. What we're looking for is side C2, the long side down here. That's what we need to calculate. How do we calculate it? Law of sines. And how does that go?
A over sine
Little a over sine of capital A
equals C1.
equal what?
C1.
Little c1 over
C.
over what?
Oh, I don't know.
Yes, you do.
C.
No.
B. A. D.
We've only done it like 3 other times, the same problem. How does law of sines go? You got the first, huh? Sine of big C1. Exactly. Huh? You said C1. C, B, A, height. Okay. How do we solve this?
C1 by itself.
Okay, do it.
Multiply the other side by C.
Multiply both sides by sine of capital C1. Okay, and that wipes out the sine of capital C1 there. Give you a little c1 is equal to, you can plug in the numbers. What's your little a? What's your little a? 12. Sine of capital C1, what's capital C1? Say again. Say again.
20.5, aren't we?
No, that's A. You said capital C1. Anyone can answer. Here's Jasmine. We have enough for a bridge table now. Okay.
Struggling to read all of your little numbers.
Okay.
And I would answer questions, I just can't see the numbers.
Okay. Can you see a capital C1 with a number by it? 94.7. Right there. 94.7. So sine of 94.7 degrees. Okay. Good deal. Thank you. Okay. Now, since a couple people have come in since made these announcements earlier, just in case you don't go back and listen to YouTube, let me say these again. Okay. Student course evaluations are open. If you haven't done them yet, please do them sometime soon. You can wait until finals are over, but don't wait very long until finals open because they're going to close them down shortly after finals. So please do them rather than forget about them, okay? That's number one. Number two, all research papers are due by Thursday. Been telling you all term, get them done. One person has turned, two I guess now. No, one I guess, has turned in a research paper in this class, okay? So get them in by class on Thursday.
I have a question. Are you dropping the lowest test grade? I don't remember if you said that or not.
The lowest test grade, but not the paper. Paper is not counted.
Okay, 'cause this
It
might
counts
be my
as a
lowest test grade,
Huh?
test 3. Test 3 might be my lowest test grade.
Okay. All right. But everything is due in on Thursday. Your research paper and all 3 tests, if you haven't done those, all of those are due on Thursday. And I'll be giving you Thursday the Chapter 6 test and the comprehensive final exam. They're take-home also, and those will be due technically by the following Thursday, but I'll take them anytime that week. Okay.
Thursday our last day.
Second?
Thursday's our last day.
Thursday's the last day of class, and then you have one more week to get your final set. Okay. Okay. But if you haven't turned in a test or the research, okay, now the research paper, if you turn it in after Thursday, I will accept it, but you lose points. Okay. But so get it in by Thursday, get full credit. Okay. Your tests 1, 2, and 3, I've got to have those in by class time on Thursday. I'd rather have them today or tomorrow or by class time on Thursday. Rather have them earlier so I can get them graded and get them back to you. Okay. And then when we get to class, I can't return your research papers because periodically that asks for samples of student writing, so I have to hang on to those for about 3 years. But I will be returning your first 3 tests to you. And once I return those tests to any student, that means I can't accept any more from any other student. So therefore, you get zeros for any test you don't turn in. Okay? Is that understood? Is that understood?
Yeah.
Okay. So, then I'll give you your test. Okay. So let's continue. So we have 12. Excuse me. I have 12 times the sine of 94.7. What else do we need? Yes, we need sine A. And what is that? The sine of 20.5 degrees divided by that, and that will give us our little C1. What does that give you?
34.15.
So C1, you say, is 34.15, and that would be meters. Okay? Well, let's just call it 34. Now, let's see if that makes sense. Okay? We have angle A, again, the smallest angle, 20.5, is opposite side 12. That makes sense, it's the smallest. Now we have B is the middle angle. Well, B1 is the middle angle, C1 is the larger angle. B1 is this, B is 31. C1, the largest angle now, its opposite side, you just told me, was 34. At least the relative sizes make sense. Okay? Let's see how the book did on it. They had angle C is either 64.8, yes, or 94.7, yes. That made little c either 34 and 0.15, but they rounded to, I rounded 34, or the other way, 24. Yes. So the 2 resulting triangles they show may be a little bit neater than mine, but not much. Okay? And there is a checkpoint there, well worth your effort to do the checkpoint. All right, any questions on law of sines so far? Got it? Any questions? Okay. Then let's move on to finding the area of an oblique triangle. Okay? Now, the procedure used to prove the law of sines, which we didn't, well, we kind of did, it leads to a simple formulation for the area of any oblique triangle, either an acute right triangle, meaning all 3 sides are acute angles, or an obtuse right triangle where the larger side is obtuse. Either one of them, this will work. Now, we know this. We know that the height of that triangle is, well, let's do it this way. The sine of angle A is equal opposite over hypotenuse, h over b. So therefore, h is equal to b times the sine of A. Even if it's an obtuse triangle, okay? Because the sine of this angle is b, it is h over b, okay? It's just that the the sine of this angle is the same as the sine of that angle because of reference angles, okay? And the sine of this angle is h over b. So that works whether it's an acute, angle A is acute, or angle A is obtuse, either one. Well, since you know the height, if you know the base, C, then the area of a triangle is 1/2 the base times the height. 1/2 the base times the height, which is 1/2 BC times the sine of A. Right? 1/2 BC times the sine of A. And if you did any other angle, it's the same deal. So, consequently, the area of each triangle, 1/2 the base times the height, so 1/2 C times B sine A. So 1/2 B sine A. By similar arguments, you can develop the formulas area be 1/2 AB sine C. So you got to have all three letters there. You choose these two sides, then you use the angle that's in between those two sides. These two sides, the angle in between. These two sides, the angle in between. So 1/2 AB sine C or 1/2 AC sine B. Okay, got it. Thank you. All right. So that's the area of an oblique triangle. A pretty simple way to go, and you don't need to know height. All you need to know is one angle and the two sides on either side of that angle. So the area of any triangle is 1/2 the product of the lengths of two sides times the sine of the included angle, the angle in between those two. So the area is 1/2 BC sine A, 1/2 AB sine C, or 1/2 AC sine B. Note that when the angle is 90 degrees, the formula gives you exactly a right triangle because the sine of 90 degrees is 1 and 1/2 the base times the height. The height is one leg, the base is the other leg. Okay. Similar results obtained for angles C and B if they're equal to 90. Okay. So here's example 6. Find the area of a triangle, a triangular lot having two sides of length 90 meters and 52 meters and an included angle of 102 degrees. So let me write the 90 meters here. Okay, this will be 90 meters. And the angle is 102, which is just past 90. So something about like that. And make this 52 meters. So this is your angle in between of 102 degrees. So that triangle. What is the area of that triangle? What would be the area of that triangle? 1/2 times 90 meters times 52 times the sine of 102 degrees. All right. Now, just because I'm pretty lazy, I'm going to take half of 90 and make that 45 meters. Okay, so I don't have to worry about dividing later. So 45 times 52, I could have taken half of 52 too, it didn't matter. 45 times 52 times the sine of 102. What you get?
2,289.
Say that again.
2,289.
289 square meters. Okay? Let's see if that actually makes any sense. 90 times 52, actually that would have been a much easier thing to do. 90 times 52 would be 468, and half of that, yeah. Seems like too big a number, isn't it? Because 100 times 52 is 520. How could you get bigger than that? Because you take a half of it, and this is less than 1. So that seems like way too big a number, isn't it? What's that?
That's what I got. That's what it says in the book.
Really? Did I copy something wrong? Okay. I'm doing the math wrong. Oh yeah, I did. Sorry about that. Okay. 100 times this would be 5,200. Yeah, and half of that. That looks reasonable. That looks reasonable. Okay. Good deal. Square meters. What's that? Okay. Checkpoint. Be sure you do that, especially if you have any doubt about how we did the last one. Okay? Oh, wait. I forgot. This is one they have here. So let's erase that ink and see what they get. Consider A to be 90 meters, B to be 52 meters. The angle C is 102. Not far off from what my drawing was, but maybe a little neater. And then when you do that, plug it in, and you get 2289 square meters. Got it. All right, let's look at the application problem. The course for a boat race starts at point A, that's the one up here, okay, and proceeds south 52 degrees west. Now, what do we mean by that? Look south and then move 52 degrees west. That's a little over 45 west, okay? And at that point, then to direction, go to point B, must be a buoy out there or something, and then to the direction south 40 east. So again, look south and do 40 degrees east, just a little bit less than 45 degrees, and go down to C, okay, to point C, and finally back to A, and they show A as being directly above C. In other words, due north of C. Now, there wasn't really any thing in the problem that said it's due north, and you just have to take the word for it from the picture, because there's nothing that you could use to verify that. So you just have to take that. Okay. It says that point C lies 8 kilometers directly south. Oh, there it goes. Directly south of point A. So it is directly south. Approximate the total distance of the race course. So, how would you go about doing this? You're given 2 angles and 1 side. The trouble is one of those angles is not.
Well, if angle B is 40, then angle C is going to be 40.
Absolutely, because this is due south here, this is due south here. Those are parallel lines. A bisecting line, you have alternate interior angles of the same. So this is also 40 degrees. Okay? Now, all we're interested in is side C and side A. We know side B. This over here, 8 is little b, right? So how are we going to get our sides C and side A? Second, law of sines, how would you do that?
Little a.
Second?
Little a over sine 52.
Okay. Did you say little a?
I did.
Okay, little a what?
Over sine 52.
Over sine of 52, okay.
And little c.
Equal little b over sine of capital B. Is that what you said?
Yeah.
Okay. I know what little b is. What's that?
Little b is
8 kilometers. But guess what? I don't know sine B. I don't know what capital B is. Or do I?
all the inside, like the inside will equal 180. So
Okay. So
figure out that angle.
what is that angle? 88 degrees. Perfect. Now we can do it. Little a over sine of 52 degrees is equal to 8 over the sine of 88 degrees. Okay? And how do you find out what little a is? Okay, and what does that give you? A times the sine of 88 degrees, 8 times the sine of 52 degrees. So then what would you do? How about dividing by sine of 88? Okay, and what would that give you? Say again? 6.31? Okay. I'm just going to round it to 6 kilometers. I know it's a big round off, but they only gave us the others 8 kilometers, so we can't really do a lot better than that. Okay, that gives you A, and that's the one over here, is about 6 kilometers. Okay? What next? Okay, we need a little C. So how do we get it? Okay, and how does that go? Eight over sine of 88. Okay, I'll buy that. You said little c over sine of what? Sine of 40 degrees. Okay, and what does that give you? Okay, and what does that give you? 8 times the sine of 40 divided by sine of 88. Is that what you said? Is that right? Yeah. Okay. What does that give you C to be? About 5 kilometers. Okay, let's see if at least the relative sizes make sense. Obviously, our largest angle here with the largest side opposite. Obviously, the smallest angle here with the smallest side opposite. And the medium side here, the middle there, and the middle side here. So the question was, approximate the total distance of the race course. What would you say?
19 kilometers.
About 19 kilometers. Okay. What did they say? Well, we'll see what they said. Okay. So the race course would be approximately 19 kilometers. Okay. Let's see how they did it. I think I can just move to the next slide. Yeah, because the lines BD and AC are parallel, it follows that the angles, those two angles are equivalent. So that makes 52 and 40. Subtracting from 180, that gives you 88 degrees. Well done. Using the law of sines, A over sine 52 is equal to B over sine 88, which is equal to C over the sine of 40, but we know B is 8, so that would be A is equal to 8 over 88, sine 88 times the sine of 52, which is about 6 kilometers, and C would be 8 over sine 88 times the sine of 40, and that would be about 5 kilometers, and so the total distance would be about 19 and a half. We said 19. So, close enough. Make sense? Well done. And that ends the section. So let's do the vocabulary. Fill in the blank. And blank triangle is a triangle that has no right angle. Oblique, exactly. Number 2. For triangle ABC, what did you say? Something not oblique? Okay. I didn't think so either. Yeah. Okay. Yeah. For a triangle ABC, the law of sines is that A over sine A is equal to blank, which is equal to C over sine C.
It's B over sine B.
Excellent. Number 3, 2 blank and 1 blank determine a unique triangle.
Sides and one angle.
You're correct. Another would be 2 angles and 1 side. Okay? The 2 sides and 1 angle, yeah, that would work too, with some laws of sines, not all of them. Okay. Number 4, the area of an oblique triangle is 1/2 BC sine A, which is the same as 1/2 AB sine C, which is the same as
1/2 AC sine B.
Got it. Super. Homework exercises. I would do 5 or 7 with pictures, and then any of the odds 9 through 23. Then do any of the odds 25 to 33, either 35 or 37 or both. Any of the odds 39 through 45, and then any of the odds 47 through 55. Okay? Then there's an exploration there, at least 2 true false. Know why those are true or false, and a graphical analysis if you'd like to do that. So we're through with 6.1. Any questions on 6.1? Oh, yuck. Okay, hit the wrong one. Let's move on to law of cosines. If there's no questions on the law of sines, let's move on to law of cosines if this will open. I think it will. Okay. All right. Continuing chapter 6, additional topics in trigonometry will now move to the law of cosines. Now, what 2 types of angles, 2 types of situations that the law of sines work? Law of sines. One more. Don't do that one. Okay. Side, angle. Okay. So that makes the law of cosines useful if you have side, or side, angle, side. Law of sines will never work with those 2. Okay? We'll also use the law of sines to model and solve some real-life problems. And then there's another formula called Heron's area formula to find the area of a triangle. And this time you don't need to know an angle. All you need are 3 sides, which are usually things you can measure easily. Angles are not easy to measure easily. Sides are. Take a tape, lay it down, measure. Okay. So we'll get to that last. So let's look at first, 2 cases remain for the list of conditions needed to solve an oblique triangle: side, and side, angle, side. So, if you're given 3 sides or 2 angles and 2 sides and the included angle, none of the ratios of the law of sines would be complete. You've got to have one ratio complete: angle to side, angle to side. This doesn't give it to you, and certainly that doesn't give it. So such cases use the law of cosines. But that's why side angle does, because the side angle, this angle corresponds to one of those 2 sides. So you can use law of sines. But side angle, side, no. So here's the law of cosines. Now, the first part of this, does that look familiar? What does that look like? It looks like Pythagorean theorem. We're just doing an adjustment to the Pythagorean theorem. And what that is if you know the two sides of the included angle, you know B and C and the angle A in between, this is what you do. That one that you're looking for, A squared, is going to be B squared plus C squared minus 2BC times the cosine of A. 2 times these two times the cosine of that angle in between. That's the thing you know. You don't know this. But same thing works for the others. If you're looking for B, A squared, and you know AC and the angle B, that would be side, angle, side. It would be A squared plus C squared minus 2AC, these two, times the cosine of the angle in between. Or C squared would be A squared plus B squared minus 2AB times the cosine of the angle in between. Okay, that's if you know, two sides and the angle in between. What if you know three sides and you're looking for an angle? Well, in that case, what you do is solve for cosine A, meaning you subtract B squared and C squared, okay? No, I'm sorry. Add this to the other side and subtract A squared, then divide by 2BC. So you get B squared plus C squared minus the A squared, the one you're looking for, divided by 2BC. Or if you're looking for angle B, A squared plus C squared, the two you know, the two that's not this one, minus the one that is opposite that one, divided by 2AC, or cosine C would be A squared plus B squared, minus the C squared, divided by 2AB. So these, any one of those three, if you know two sides and the angle in between, any one of those three, if you know the three sides, side, side, side. Okay, let's do example 1. Now, this is side, side, side. They give you the three sides of a triangle. You don't know any angles at all. All right. Now, here is a very good thing to do when you're using law of cosines. If you have the three sides, always go for the big angle. Always go for the big angle, because that big angle, the big angle, it's got to have a positive sign, cosine. So you want to have, well, I think you'll see when you work it out. It's a good idea to find the angle opposite the longest side. And let's do it. What would be your rule for that one?
Well, the longest.
Go for the big angle, yeah.
Big.
So that would be cosine capital B is equal to A squared.
14.
Okay. Oh, you said 8. I thought you said A. Okay. Yeah, we'll go on and plug in then. Okay. 8 squared plus 14 squared minus 19 squared. 2 times 8 times 14. Got it. Now, here's the reason we do it this way. Okay? If you did one of the other two, you might have two possible angles that it can be. This one is only going to be one. If this angle is negative, and it looks like it will, it's a positive angle, but if the cosine is negative, that means you've got to have something greater than 90 degrees. Okay? Whereas if you have positive, there might be a couple of possibilities. But that's why we go for this one. If you'd done it the other way, you see you might run into some problems. Always go for the big angle. Okay? So, what do you get? Plug and chug. 64 plus, I can't remember that one, 296 or something like that. By the way, you might also notice this is a 196. Okay, so this is feet squared, feet squared, feet squared. Foot times foot is foot squared. So all your units go out, which is a very good thing because cosines don't have dimensions. Okay. So anyway, what you get? Pretty sure you get a negative number, right?
Yeah, I got negative 101 for the top.
Okay. What'd you get?
I did the whole top.
Oh.
I got negative 101.
Okay, and then divide by whatever. Because 19 squared is bigger than the sum of these two squares.
Yeah, but negative times negative.
But these are all positive.
You still have to do the baseline.
Oh, okay.
Okay.
I thought we were just adding.
No, you're not adding. You're,
But on
okay.
your-
8 squared plus 14 squared minus 19 squared. And then whatever that is, divide by that.
See, I did negative 19 squared.
No, okay.
So I was like, that's what I did.
Okay, it's minus a 19 squared.
It's going to be negative 0.45.
What is that? Just the top?
No, that's
Oh, the whole thing is what? Negative what?
0.45.
0.45?
Yes.
Okay. All right. All right, good deal. Good to see you. Okay. Chevette is here. Okay? Good deal. Thank you. All right. Now, how do you get B then?
You do the inverse
Inverse
of cosine.
cosine. And what does that give you?
Gives you 116.8.
116.8 degrees. I think I'll just round that to 116. Not 117. About 117 degrees. Okay? Now, where would you go from there? This gives you 117 degrees. What would you do next? You have 3 choices.
Well, you need to find angle A and angle C.
Okay? And how would you go about doing it?
Cosine.
Okay, you could do law of cosines again, or since you now know an angle, you can do a law of sines here and get either one of those two. And once you get one of those two, please don't do another law of sines or cosines.
No, just do
Subtract from 180, exactly. So that's what you would get. We'll just pretend we did it. That gave us 117 degrees, and then they did a law of, the law of sines, and came up with B is equal to, A is equal to 22.8. So we'll call that 23 degrees. And then you do the difference and you get 41 degrees. Okay. Sorry we had to rush that. We'll pick up from there next time. Example 12. Okay. And homework exercises in this. We didn't get very far, but you should be able to do any of the odds 5 through 11. No, any of either 5 or 7. Do 5 or 7. We'll do some more next time. Yes, sir. Ready? Okay, had you started yours? You hadn't, had you? Okay. All right, you want to stay in here? Because you don't have to go over there. There's no class here until 1:15. Okay? Or if you want to come down closer to my office, you can do that. Did you already turn in the quiz? You did, didn't you?
Yes. I turned it in when they started taking the test, because we had a game, so I came.
Right, yeah. I thought you had. So, all right, you need graph paper.
Yes.
Okay? Let me see if I can find some. Well, I know I have some. There it is. Yes, sir. What's that? It just finished. He's taking a makeup test. Okay. Do you need the key?
I'll stop the recording.
Yeah, I will. Do you need the key?